as aerospace engineers, we are so focused on the aircraft itself, but operational, readiness and operational safety is a different beast of a engineering effort altogether.
ATC at LaGuardia, they would also be monitoring ATC operations that are happening in the neighboring airports in case there is some sort of an emergency, while also catering to the heavy volumes just local to LaGuardia.
The Potomac incident earlier this year, military chopper came into the civilian space. Again, that's an ATC responsibility to make sure those two things don't come together, right? How does civilian airspaces get aware and get notice without breaching the privacy of the military protocols?
It's a retired Air Force pilot who had said when we started flying, there was no screen, there was nothing. There was just a pilot with a good logical brain and minimum amount of information, and we had to fly. But these days, there is such an information overload for a pilot that sometimes we are put into the state of indecision.
Unfair that they keep saying that they used to fly without screens or much information. Well, they didn't have much traffic to fly with as well, so they forget to say that. Let them do that today. They can't.
It is an interesting time in Mumbai because the Navi Mumbai airport is now going to be open, I think, very shortly. So that is additional operations that have started in this entire area. So a lot of high volume flying from a very small area overall.
I will never trust pilots, I guess. But
unpopular opinion.
Unpopular opinion. That's what my goal in my career is, to make sure there's no requirement of pilot at some point.
When we sit in aircrafts and we look at our TVs, there is a camera under the belly of the airplane. So can such cameras then be used for following an illuminated path on a runway, and they follow that autonomously, and you have somehow a feedback loop sent to a central software, and they don't allow two planes to be colliding into each other?
Systems are not built for failure. They have been checked, double checked, triple checked to make sure these incidents never happen. 99% of the time they don't. Hey guys, welcome to another episode of Ground Control to Major Nerds. My name is Sri, and I'm joined by my constant co-host, Ashwini. Ashwini, how are you doing?
Good. Quite busy. A lot of festivals happening in India. Just navigating all of that, apart from hectic work schedules.
Yeah, hectic work schedules are the right thing. It's going good, right? From your end, and definitely from my end as well. But also we have a lot of good episodes coming in the future. We have some really interesting guests that we cannot reveal right now. But in today's episode, we'll be talking more about the theme that we were starting off with, ground stations, and we were talking about safety in the past. We were talking about different kind of aircraft systems and ground systems as well. Continuing the same theme, this is more in regard to the airport systems and the airport situational awareness, the surface system. So one of the incidents that just recently happened on October 1st with the two Delta regional jets is what we're going to talk about in today's episode. Ashwini, would you like to start us off?
Yes. So just basing off of what has happened to people who don't know what has happened and what is the incident. On the night of 1st October, two Delta regional jets, both of which were Bombardier CRJs. They were being operated by Endeavour Air, which is the regional counterpart for Delta. They collided while taxiing at New York's LaGuardia airport. And one had just landed in. They had just arrived from Charlotte. And the other one was preparing to depart for Roanoke. And at the taxiway intersection, the right wing of the departing aircraft struck the nose of the arriving aircraft. And while it was a low-speed impact, it still shattered the cockpit windows, and it also tore off part of the wing. And while thankfully there were no fatalities, no serious injuries, one flight attendant was injured, and thankfully no real serious damage. It was a low impact damage, but highly costly damage. I'm pretty sure it was very costly for the airline. And it's just another incident that has happened, which again draws attention to sometimes things that we overlook, which is how complex and risky ground operations can be. It's not just about flying and being safe up in the sky, but also being safe on ground. So that's what I had on this incident.
So like Ashwini said, and this is, I think, getting a little bit more familiar in terms of the incident itself. Like recently on February 1st, the same thing happened with the Japan Airlines and Delta clipping the tail
Exactly.
section at the Seattle Tacoma Airport. uh, it, it's two incidents in a year. I know people might think it's only two, but in general, there have been a lot of reports of near misses also happening. Even though the near miss count has been reducing over the years. Like in 2023, it was around 1,700. In 2024, it was 1,400, approximately 24 to 17% reduction, like over year. But the incidents that are then leading up to accidents are actually like familiar, and they're coming out and they're popping up on in the news, and it's happening. Basically, that's what I'm trying to say. So this is something I think the industry is also like driving towards, that aspect of developing better surface awareness and operational systems. I think I know Honeywell has already like done its research on doing that, and also Collins is. But regardless, coming back to this incident, Ashwin, so what do you think would be some of the factors or in which this kind of a situation could actually happen, where two aircrafts should not be in that same like in the same location during taxiway?
That is the part that we don't know right now.
Yes,
So,
we don't know,
like I
but
said,
in terms of just like our experience or our understanding of how the ground operations happen, what do you think would be the few things? I know obviously the report will come. The initial report just says there was a nose section damaged on the departing aircraft,
exactly.
and but in general, though, what could be the few things that people may not consider while taxiways operations are happening, or airline operations are happening on the ground level?
This is exactly sort of speculation what I've written down, and I'll just
Hmm.
refer to this. Basically, we don't know if there was misinstruction or misunderstanding of instruction. That could be number one, where communication that has happened with the ground control tower. There could either be a misinstruction or there could be a misunderstanding of the instruction given. And typically, the instruction in this case would be a holding short sort of instruction where you're just holding off before taking off. That could be one. That could be uh, uh, hindering this sort of safe operation where
Yeah.
just the
So this
weather, if
incident,
it
yeah.
was
So this incident, I'm sorry to interrupt you, but this incident happened during the night time. So I just wanted to give that perspective. So yeah, go on. Sorry.
right. So lights, there are a lot of very bright lights that light up your taxiway, light up your runway. It is possible that glare or reflection from these lights could have made the pilot avoid seeing an aircraft right next to their own aircraft. That could be an issue. And then otherwise, I'm pretty sure LaGuardia has a pretty robust and a modern radar system, and the ADS-B pings coming in, that is something that is being monitored live. But this could also be part of it where there is a technological failure, where equipment that is maintained so that they are keeping a robust check on actual flight patterns. Was that maintained? Was that working without any error in them? There could be some error on software or on the screens or on the background software that is managing these events, these complex events. So that is something that could also be a cause. And it looks dramatic, but what we know is that the reality of ground operations are that they are complex, and there could be a multiple series of failures, or there could be one very small thing that has led to this large failure, which is ultimately, now in this case we are calling it a large failure even though we know that there are no fatalities. A few episodes ago we discussed the flight 171 Air India crash, and that was a major crash. So in this case you cannot compare the two. There are no fatalities, but even then such small incidents also are equally important for us to learn from and to understand from what could have gone wrong, and which is why we are all eagerly awaiting what the NTSB and or what the FAA says about this. So from my side, this is the only speculation I could think of what went wrong. What do you suggest?
No, yeah, I think you actually covered up most of the points. The other aspect and the other perspective I want to bring to the table is that even though there are robust systems, even though there's a lot of data that actually keeps processing throughout the operations, that in itself is a hindrance that sometimes we don't realize as designers of systems. Like there's so much of data, there's so much of data points from different aircrafts that's coming to the centralized system, then provides information for the air traffic controllers on the ground for dispatch to make sure that they try to like coordinate this but coordinated chaotic game that they have to play with which aircrafts come in at what time to taxi or to to line up to the runway. Sometimes it can be missed. There is a human factor element that's involved that could be having a failure that could cause this. And for this reason exactly, since the air traffic is increasing and the number of flights that are taken from every single airport, especially LaGuardia is a big airport. It's a big domestic hub in New York, right? So it's one of the three big airports in New York. So this thing, I think the frequency or the probability of failure is now getting realized more often because of that, you know, complexity that's being built up with all the data that's coming in. So I think,
If I can
yeah.
ask you a question here,
Hmm.
basically what you're suggesting is the sheer volume of flying that's happening
Hmm.
is one thing, and then the fact that we are giving massive amounts of data related to all of this flying live to people, actual people on ground, and they have to then sift through all of this massive amounts of data in a very short period of time and give the correct information. Is that so? Because that would be a human factors issue as well, where
Yes.
you are just going through massive amounts of data in a very short amount of time and trying to give the right instruction.
Exactly. So in pressure situations, some things could be missed because it's human factors, right? But again, the systems are not built for that. Sorry, the systems are not built for failure. They have been checked, double checked, triple checked to make sure these incidents never happen. And they do. They usually don't. They never do. 99% of the time, they don't. You never ever notice when you're traveling, as a passenger, you will never even notice this could be a probability of failure, right? But when it happens, then you have to learn from it and you have to
Exactly.
understand it and you have to deep dive into it. And that's what I think, obviously, all the, operators and the airports system designers and also the airlines will have to retrospect in. Like in this case, Endeavor would actually understand, okay, how did this incident happen? Did our ground operations, procedures are something which are more tedious than being simpler? Simple things like that could be a case. Or maybe it's just a sheer volume of data that's coming to the air traffic control, which is then causing maybe these kind of near misses slash accidents happen more often, because 1,000 incidents is still a lot. Like, we can do a lot of good, development to avoid even the 4-digit number, right? So that's my viewpoint of it. And yeah,
Before
yeah.
you move on to slightly more different topics about this,
Hmm.
just one more question on the same sort of path. Uh,
Hmm.
the entire area of New York has three airports currently, right? There's
Yes.
Teterboro, there is LaGuardia, and then there is Newark Airport, right?
No, Newark is New Jersey, so it's JFK is the big one. So JFK,
JFK, sorry, JFK,
yeah,
yes.
yeah, and then there's an airport in Long Island too, but that's still like a very smaller operational airport. But still, there are four airports in New York, if you consider that. But
So
yeah,
for someone working at the ATC at LaGuardia, they would also uh, in their periphery be monitoring ATC operations that are happening in the neighboring airports in case there is some sort of an emergency where someone has to be diverted to LaGuardia or something like that, while also catering to the heavy volumes just local to
yes.
LaGuardia, correct?
Yes. Also, just to give some clarification, it's not one ATC operator trying to do this. There's obviously a team of it,
Of
and
course, of course, of
every
course.
segment of the air traffic management is done by different operators. So dispatch is done by dispatcher. Uh, you know, uh, Departures, arrivals. Like there are different aspects. I'm not completely savvy about those terms, but I know that there is 4 to 5 different sections of the air traffic operations that happen, and there is one or two people who are operating that each segment of it. So yes, definitely there is like multiple people, not just one person trying to manage multiple airports, but at the same time it's still an what do you call it, sensory overload of the data that's
Of
coming
course.
in, because they still have to sift through the processes that are built in, and they have to follow those processes there. While they're following protocol and processes, they still have to be situationally aware of what is happening, because maybe those ATC controllers are in like uh, using the procedures correctly, but maybe the pilots are not sometimes, or they have misunderstood the commands or they misunderstood the directions, and then they have to quickly react and correct those commands and corrections that the pilot is doing. So there's a lot of in inter uh, intertwined situations that are happening over here, which can become complex very quick when there's a stressful environment. That's I think one of the speculations that I'm making that could have caused this incident, because none of them are like, I don't see a gap in like the procedures or the protocols that have been set up by the airlines or by the airport. They have, I think, double, triple checked those protocols to, perform correctly. But in a high volume, high density situation, maybe those protocols may have to be revisited. So that's what is my speculation on that.
The only reason I bring it up is because it is an interesting time in Mumbai right now as well, because the Navi Mumbai airport is now going to
Hmm.
be open, I think, very shortly, maybe in the next 1 or 2 days. The first
Oh, yeah.
flight is coming in from Delhi to Mumbai into the new airport there. So that
Hmm.
is additional operations that have started in this entire area. So now
Hmm.
you already had the Santa Cruz and the new airport both running through those runways, which had a massive amounts of
Yes.
massive volume of flying. But now you also have this additional flying zone that's come out of Navi Mumbai. Not to mention that there is this Pawan Hans zone in Juhu, which is for helicopter operations and small aircraft. So lot of high volume flying from a very small area overall.
Yeah.
It would be an interesting time to be someone just looking at operations in the ATC. And it begs a thought that if there is local ATC for each of these airfields and for each of these airports, is there like a super ATC which is managing all of these? And if so, what are the protocols here? So I think that would be an interesting conversation to have someone
So,
from
yeah,
who works
exactly.
at the ATCs.
Exactly, yeah. If we could get them on, or if they're listening and they're interested, reach out to us. We'd be more than happy to, deep dive into that.
I actually do know this person who works with the Airport Authority of India. They are also part of. So I recently attended this Aeronautical Society of India Mumbai branch meeting. It was the annual general meeting. So I was acquainted to this gentleman who works with the Airport Authority of India, and he's in charge of the ATC at the Mumbai airport. So he's a very busy man, so I couldn't spend a lot of time talking to him, but hopefully in the next few days I get to meet him, I get to talk to him because of
Interesting.
Aeronautical Society work. And it would be an interesting thing if he's available. We would definitely like to have him on.
Yeah, absolutely. Because that's okay. As aerospace engineers, we are so focused on the aircraft itself and the design of it, which is, by the way, very, very interesting and also important to do. But operational, readiness and operational, safety is a different beast of a like engineering effort altogether. So, writing the right protocols, making sure those protocols are adhered to, how they get introduced into a change. For example, a change that needs to be done right now from legacy air traffic systems. That's a big change that needs to be adapted correctly, because you cannot just abruptly bring in as well. So there's a lot of things at play over here, right? So yeah, somebody like him might shed a light on like how does
Maybe.
a new protocol get introduced, or what are the current protocols that make us fly safely. Like the Potomac incident as well earlier this year, when like a military
Yes.
chopper came into the civilian space and had a massive catastrophic incident that happened with so many lives lost, right? Again, that's an ATC responsibility to make sure those two things don't come together, right? The military chopper and the aircraft. And that has also sparked a lot of debate and also a lot of research on how can we track military artifacts coming into civilian airspace, and how does civilian airspaces get aware and get notice without breaching the privacy of the military protocols, and make travel safer, right? So these kind of things are now again opened up and are to question, because they were never questioned because none of the incidents happened before. But this year we are seeing a lot of these incidents happen more than ever before, I feel like. And maybe it's a good time to start thinking about modernizing these air traffic management systems. So yeah. Which brings me to the next point, which is what I think I am very interested in, which is the modernization of the air traffic and the NAS system that we call to talk about the National Aerospace Systems. There is a lot of initiatives that are getting done, and I think this incident like reminds me of one of those developments that was started to grew in 2015 2013 timeframe when next gen program, which is the FAA's next gen program, was trying to tie up with the European agency's CESAR program. They were trying to come together and develop a new age surface, detection, surface awareness systems for airport operations. So I think modernizing those systems, I think, becomes like a necessity now. And I think there's a lot of good uh, systems that are getting developed by Honeywell and Collins and other OEMs that are making it. And they're using very simple concepts which are already existing in the framework, which is the satellite-based broadcasting systems like the ADSB. They're using ADSB heavily on the ground as well. So the problem with ADSB is it's usually used on airborne operations, but they have started seeing of some sort of an ADSB variant for ground operations as well. And then using that ADSB data, they're trying to make sure that they can have live tracking of each and every aircraft after landing. What do they do? What is their protocol? What is their situation and their attitude and their speed on the ground itself, and what is its intent on where it's going? And this ap- apparently is going to get more automated, more sophisticated, and more data driven with simpler data, not just like a chain of data coming to the air to the pilots and the ATC, but much more of an automated, like much more of an informative data set coming to the pilots and the operators. So this is something I think in the future it would be like interesting to see once it gets deployed.
Before you go on, to listeners who may not completely know what ADSB is this the same technology that we use on websites like Flight Radar to track flights coming into airports, leaving airports? Next time I have to pick up my mother while she flies in from a different city into Mumbai, I'm referring to something like a Flight Radar to see when is the flight landing. Basically, these are all using ADSB pings coming to ground and then giving us that flight tracking information, correct?
Yes. So ADSB is automatic dependent surveillance broadcast. The B is the broadcast. There's ADSB-C, and then there's ADSB different variants of it. But ADSB, which is the broadcast, is what live radar, like the flight radar and live tracker softwares use. They are 5 minutes behind than the live, operations, obviously for privacy reasons. But yes, these are the technology that already they are available for free when we Google like to track a flight, basically. So flight operations use it. Pilots may use it for just understanding where their next leg of the flight is looking like, to for their own operations, and also obviously the airports use it. And ADSB is heavily used in airborne systems, like TCAS uses it. The transponder system is now incorporated with ADSB so that live satellite-based broadcasting can also happen. And um, it is a very, very independent, well-tested, well-versed tool for the last 15 to 20 years used in the aviation industry. So bringing that to ground operations is just another step forward to utilizing its full potential, basically, for awareness
So
purposes. So yeah.
just thinking out loud, if you notice these free websites that give you this airline information, they always seem to have this graphical representation as well. Once a flight lands into an airport, before it lands, when it's flying in the air, obviously it's still quite a voluminous sort of data explosion in your face, and there's a lot of flights coming in. But in an airport, there will be a number of airplanes parked. So won't that be a very heavy density sort of ADSB? If you're plotting these ADSB points on some sort of a map, won't it just be a very high density sort of field? So for on an observer who's say at the ATC, how at the ATC tower, how do they navigate through that? Is that just like white dots all over your screen? Is the data too much, or do you have a large enough screen so that data is not overlapping each other? What sort of protocol are they thinking of there?
Yeah, so that is the challenge right now, right? So the modernization of the air traffic systems, that's the challenge because In air, there's a separation, and you can clearly know which ATSB ping belongs to which aircraft.
Exactly.
Now, again, obviously, each dot of the ADSB ping will come with 8 or 9 different data points of like what tail number it is, what was its origin destination, what is its, what was origin, what is its destination, what speed it's going with, what altitude it's going at, it's what altitude it's flying at. So it's those data points are easy to then demarcate on an aircraft when it's in the sky. And also, like, there are some regulations where below 1,000 feet, I don't think so. The transponder even is like required to be operational because I think of those same reasons, right? Because no, sorry, not transponder, but PCAS. Sorry, the traffic collision avoidance system stops using the ADSB data because they would not be advising any aircraft to go up or down at 1,000 feet. So things like that. And also the reason is because at below 1,000 feet, you're going to start looking at the aircraft from the ground, and the system's going to start getting confused, like, oh, there's so many aircrafts now, I need to avoid them, right? So the system gets overloaded on the ground with a lot of ADSB data points, which is the right you know direction that you went with that question. So that's the challenge. Now, how do you segregate and how do you maintain a proper understandable map of the location of each aircraft on the surface? So there are different techniques that can be used. One of them obviously is using some sort of a machine learning slash what we call AI in aerospace. So some machine learning techniques could be used wherein they use data which the operators generate and give, where they know which taxiway, which taxi aisle those aircrafts are at, and maybe remap the ones which are moving. So basically, there are different you know, uh, uh, segregation techniques that we use. Ones which are moving, ones which are stationary, ones which are scheduled to take off, ones which are scheduled to land. So there are different patterns that are generated, and then those patterns are then automated to see how those schedulings work. That's one way of using just the existing data, not upgrading your system. The other way is to introduce a new surface radar, and which is already existing by the way on in the airport, because that's how the ATC understands where exactly everybody is. If, for example, one aircraft decides to go rogue, which never happens, but if one aircraft decides to go rogue and not provide its information of what its position is on the airport, the ATC will be having some way to figure out where they are and what their location is on the airport, right? Like in which location are they on what taxiway they want to go and stuff like that. So that technology kind of exists in not in every airport, but in most airports. And using that technology, then you overlay that data in real time with the ADSB data, and then you figure out how you can present that data correctly. And then there is a probability of automating that, meaning you without the air traffic controller coming in the loop and giving you guidance, you as a pilot will have information live, ready to ready to be seen on your screen, so that you can then make your decision if required during stressful scenarios like this, when you may see an aircraft in front of you but you don't know if that should be there or not. You can then know from that screen itself directly that, okay, this should not be here, but I'm going in its path. I need to either stop or make sure that I confirm what the action over here should be from the ATC. So these are a few flavors of the surface IA that are gonna be developed.
You know, listening to you talk about this, I've just had three very distinct memories, which could be
Hmm.
ideas that I'm going to suggest to you now. A few years ago, I had seen this documentary on Nat Geo. This was about the port in Amsterdam, the shipping port in Amsterdam, where
Hmm.
they had introduced a system where the port vehicles, not the ones in the sea, but the ones that are at port, whether those are cranes or loaders, unloaders, passenger carry vans or trucks, and goods carriers. All of these were going to be following an automated path system where a path is made, it is illuminated, or it is made from a material that illuminates, and then they put sensors under those vehicles and they follow a path. And they all
Hmm.
have sensors that are able to track each other so they don't ever collide with each other. And they were going to automate all of this so that they also had issues with human factors where drivers were not careful and they were having these accidents. So they decided to take it out of the hands of the drivers and give it to a software. So they were all controlled by a software, or they were autonomously operating in the port. And the guy had said that very soon the ships coming in from open sea, once they come into port, they are usually they use tugboats to navigate through the narrower channels, and they bring it to port, or they bring it right next to the loading unloading station or the dock. So that would also become an autonomous process where tugboats would not be piloted by a pilot, but rather it would be autonomously operated. Now, I'm not sure whether that is something that has been in practice. I'll have to actually Google this. But similarly, could we have something where aircrafts, once they come into land, they follow, they have sort of camera systems, and these are something that planes already have. When we sit
Mhm,
in aircrafts and we look at our TVs, there is a camera that is pointing down, right, under the belly of
mhm.
the airplane. So can such cameras then be used for following an illuminated path on a runway, and they follow that autonomously rather than a pilot doing the taxiing? So there are lesser scopes for errors, and you have somehow a feedback loop where these planes are then sent to a central software, and they don't allow two planes to be colliding into each other. I think that would be a great sort of research point.
I mean, obviously, as an engineer in this industry, I would like to have least amount of operations done by pilots, as you may know. Even though pilots would hate me to say that. I will never trust pilots, I guess. But um,
Unpopular opinion.
unpopular opinion, that's what my goal in my career is, to make sure there's like no requirement of pilot at some point in flying. But obviously that's not, I don't want to speculate on, like, or go towards that direction. But uh there, I mean, yes, maybe there is a world in which that could happen, but also at this moment of time, I think that automated tugboat system may not happen, only for a reason of safety and for robustness, because aerospace is such a safety driven, double, triple redundant, industry. Um, I think they may not rely on automated tugboats. I don't think so. The operators or the airports will be, comfortable to do that. But at the same time, removing the tugboats out of the equation, just in general, I think the biggest concern over here, or the biggest problem over here, is the visualization of the ground operations that the pilots do not have real time data for. Now there are a few things that are getting introduced, which are slowly and slowly becoming a norm, which is one, we call in this industry called TPADS, which is portable electronic devices, and which can transmit data as well, which is basically a mobile, but something bigger than a mobile, maybe like an iPad, which is getting allowed more often into the flight operations, right? So there's iPads that are coming in where NOTAMs are coming directly to the pilots, weather
Right, right.
information, the flight paths, the plannings, the FMS data that was supposed to be manually put nowadays into the aircraft, they can plan it on an iPad and just come in and maybe sync it up on what the iPad has to the aircraft, rather than sitting over there and doing those things, sensitive things in the cockpit itself. So once that stage has now come where the pilots are bringing their own devices, operators are bringing their own devices, maybe it's a time when rather than having automated tugboats, they have real-time surface data on their big screens. Meaning once they land, they know exactly in their taxiway how many tail numbers are there to the
Right,
taxiway
right.
that they're trying to go to. That visualization in itself avoids 90% of the problem, because now they know I need to take care of these three or four aircrafts which have got their own paths to, maybe go and line up to the runway, or maybe they are also going to their own designated taxiways. So that is right now missing. The pilots are relying only on the ATC's direction of take this taxiway, go to that, your designated location on the airport. Whereas if surface IA, or systems like the surface operation system that Collins and Honeywells of the world are creating, they will now make sure that the data is much more precise, much more visualized and real time. So that the one you were talking about, the tugboats using this illuminated sensors down, rather than having those illuminated sensors, they have gates, which the airport imagery comes on their screen, and they know the gates that they need to take to get to the right taxiway and then get to the right destination. So these are the kind of real time, high data processing, and accurate information to be given to the operators and to the pilots and to the ATC, is what is the next step towards making sure the modernization of air traffic is going to. So
Tell
yeah.
me something.
Mhm.
These days, you have a lot of cars that have augmented reality as part of their heads-up display. So, like Google Maps, instead of you driving, looking off screen into a phone and seeing what the direction is, there is a
Mm-hmm.
heads-up display that is transmitting something onto your windscreen. How about a retrofit for all aircrafts where uh, pilot after landing gets all of this ground instruction rather than coming in auditory from the ATC that, listen, you have to take path L, go into this, and your parking bay is G36, which is you need to take a left from your right from there. You just have this heads up display and it tells you you need to go left here, you need to go right here. And if there is any incursion, they tell you immediately to stop. I think that would be
Yeah.
so much more
So
easier for a pilot,
I'm
right?
I'm glad you said that, because so the head-up display that, I mean, most aircrafts don't have it yet. The most commercial aircrafts don't have it yet. I would like to correct that. But I think the A350 and the 787, I think, has an option if the operator chooses to provide the pilot with the option of having a HUD, which is a head-up display, right? So like a fighter pilot style HUD, like a green screen coming in
Right,
front
right,
of,
right.
yeah,
Right.
like a glass screen, like a glass screen. So that already exists. So the pilots use that on takeoff and on landing to have certain information which they don't need to look down on the displays, but they can see straight to the through the windshield, and they have that. So Surf IA also may have this feature where the HUD will have gates for the plane to go through and then have information
Exactly.
on the HUD itself. So yeah, that is another interesting point that is in development, and I've heard about it, but I've never seen as a product description or a data sheet that's been put out. The problem with that is certifying such systems, because it's now going to impact flight operations. That becomes a major software to certify, right? So I think that's the reason why I think there's no push for it to be made immediately, because of the certification realm being that difficult to do. But I think the other option, which is the iPad having that data, is kind of like a introductory or like a entry point into that sort of an operation, because iPads don't need to be certified, and that's not the primary data that the pilot will be looking at. The primary data would be the screens on the aircraft and the ATC commands that they're getting, right? Because that's what they should be listening to as the priority data. The iPad is just a supplementary data. So that's how this data can come into this realms of surface operations, basically. But yes, there has been talks. There have been also proposals that I have heard of where the HUD, because the HUD is already giving a lot of critical data on certain flight phases, which they have been certified for. But the HUD in itself is not like a catastrophic, certified, system. The HUD is still like a lower priority system where the pilots are instructed that the HUD is not your primary source of data. Your primary source of data still has to be your displays on the screens, like on the cockpit. So I think it will take some time for that kind of an ideology to come in, like a HUD ideology for surface operations. But still, yes, that has been, I think, demoed, if my memory is not wrong, and that has been talked about, and also different flight phases having HUD data has already been shown and demoed and also certified in certain aircrafts. Like Gulfstream, for example, we got a HUD. Like when we were certifying it, we got a HUD that was doing a lot of flight phase data points that was already there, and the HUD was certified for that to use. Again, HUD is a secondary source of data. It was never a primary source of data. So pilots have to still,
Right.
if they are in doubt, use the screens, cockpit screens. Yeah, there's good amount of for probability and possibility that the HUD could be used, like how the augmented reality in cars could be. So yeah,
Exactly.
that's true.
I'm just spitballing another idea, and this I'm completely stealing from my background as a drone engineer,
Hmm.
where we are continuously working on management of swarm of drones or
Yeah, yeah,
flying patterns of drones. Now, the easiest thing to do in a closed environment like an airport would be to have camera systems in different places. So you have masts around, say, 60, 70 feet high, and you put PTZ cameras in different angles. So now you have a visual view of the entire airport. Now the airplane comes in, you have a data point. You are with your camera algorithm, you're tracking this airplane. And this data is now transmitted onto a screen where it is not just a camera view, but rather a sort of track algorithm view where you have, if listeners of the podcast, you've seen videos where people are walking and then there is this green box around them identifying. So similarly, you can identify airplanes and then you have these green boxes all over the airport. That can also be used. The only drawback of this is you will have to spend massive amounts of money building up the infrastructure of cameras, and obviously cameras. If a camera gets spoiled, your entire algorithm goes for a toss.
Yes.
So that
So
I
I
can
think
see as a draw.
that's the only reason I think that is not being even like explored maybe. But I'm pretty sure as a secondary or tertiary source of data, the airports might use it. And I think some airports do use it. Actually, I don't think so they use it for flight operations, but they use it for other purposes. Maintenance of the airport and stuff like that. Like when after each and every takeoff or landing, they try to see the degradation of the runway. Those kind of aspects, I think some airports do use it for tracking the maintenance of just the airport in itself, the infrastructure of the airport in itself. But I don't know if
I guess
flight
they have a lot
operations
of
will ever use it.
cameras for security, right?
Exactly. Security is another aspect, but in general, that same security cameras might be used for data points on
Exactly.
how to maintain the infrastructure, right? So yes, it's not far-fetched from what you suggested, but I think the only point where I think it fails in aircraft operations, I guess, is the redundancy factor. Maybe two, three cameras then maybe have to be installed instead of just one if that becomes like a primary source of data for flight operations. So maybe that's why
No,
I think people are hesitant, but yeah.
there's also one more thing here. For all drone operations where we have these external cameras that are monitoring drones, the camera as a sensor is sending data to a ground control station which is in contact with the drone, and it has the capability of altering the navigation of a drone. Right. But in this
Yes.
case, navigation of the aircraft, even on ground, is still with the pilot. They are not
Yes.
handing it over to the ATC because that would become a major security threat.
No, that will
I'm
be a
just thinking
problem.
of the cyber security lapses. If someone hacks into such a system, it could be crashes all over the place, right? So
Exactly.
so I guess that is also that there will be a lag there where you are then informing a pilot that there is a hindrance in your way, and then the pilot still has to then audibly understand that instruction and then take remedial action.
I
So
guess, yeah, I guess, I mean, it's still on the same lines, right? So the suggestion that you're making and the ADSB implementations along with the automated data processing is still on the same lines. Like, we don't want to have a lag in data for the pilots to understand what the situational awareness looks like on the ground. And that's I think, the intent of making these new modernization, initiatives is to make sure that the right data is given now, maybe not in the form of visual awareness, but maybe in the form of data point awareness. Like they might have a map with a track saying that there are three tail numbers in your track, stuff like that, right? So there there might be in the future some organization where visually also they're shown some data points of like, hey, this is what is coming in your way, and this is what you need to be aware of on your left and on your right. So things like that maybe would come. But I guess for the time being, the biggest lapse is pilots not having clear situational awareness. I guess that is where the modernization is going towards. So it's interesting. I think for me, it is one of the most interesting aspects of flight operations is the surface awareness. I think this improves the operational costs as well. Like they will significantly improve the efficiency of operational costs because right now, if you see the amount of time you're waiting on the tarmac, sometimes on these busy airports, is lack of just data going to the pilots quicker. Like each pilot has to be given an instruction from the ATC before the movement happens, and that's slowing down the operations as well. So the more time you're just standing on the tarmac, the more oil you're burning, right? So things like that can also come out as a plus through this modernization.
I just like how you stayed true to team engineer and at the end said pilots have to be more careful because you know this reminds me about 2 years ago I had attended this event where there were speakers from the Airport Authority of India, from the Air Force, from the Army. This is just discussions related to aviation. This gentleman from the Airport Authority of India, they were managing all ground operations and ATC, who was saying that this was for the discussion was to do with drones, and how there is a requirement for an urban sort of highway system where there has to be a lot of path planning. And, if you are looking at drones becoming a part of our urban skies, there has to be so much path planning for this.
Yeah.
And one of the suggestions made was that why don't we start putting sort of ADS-B sort of sensors on all buildings? And yet said this is a terrible idea because it is just
No.
completely going to all our radars, all of our screens are going to completely light up, and we're going to have so much spec issues. So this is a horrible idea. Just pilots have to be more careful. And the second person who had spoken was this retired Air Force pilot who had said that these days when he had started flying, this was an old gentleman. He had said when we had started flying, there was no screen, there was nothing. There was just pilot with a good logical brain and minimum amount of information, and we had to fly. But these days, there is such an information overload for a pilot. There is so much information coming from so many sensors that sometimes we are put into the state of indecision. There is a decision sort of lapse where you don't know what decision to take because you're
And
just looking at the information.
and here's where I think AI comes in. Like I I mean,
Exactly.
it's loosely said AI. I don't think so. It's still AI. I think it's still machine learning patterns which are coming in,
It's automation.
which it's automation, right? So precise data. I think we have got enough algorithmic computers which are built already to make sure if right situational, requirements are given, it will spit out the right data for that situation, right? So
Exactly.
maybe the use of those agents and those machine learning agents or AI agents that they call, I think that is the next step in aviation. And I'll speak from my perspective as a systems engineer. We're already using Gen AI techniques to write good requirements because a lot of times you think writing English is, oh, it's just writing English, but no, requirement writing is a skill. And you cannot have everybody write requirements correctly. I think using generative AI techniques to write requirements is becoming a thing automatic now, even for catastrophic systems as well, like DAL-A systems. There are Gen AI techniques in like requirement management tools that we're using. Same thing, the requirement management tools like are also using Gen AIs and the AI agents to write good test cases and test procedures, which humans
Right.
could not think before. So the same techniques could be used where this information overload is happening. They can dissect and summarize it correctly for that situation, but it needs to be built in properly with a proper algorithm. And that is what I think is the next step as well in flight operations, where these iPads are coming in, these CPEDs are coming into the cockpit, and not to even mention, not to reveal a few things that I'm actually working on, where satellite-based communications are being used for giving live information to pilots about their flight paths. Right
Right.
before, they were all reliant on some database they used to download on the ground and then make sure that in flight they're using that. But right now, we can give them live weather patterns in the sky while they're in the cockpit to make sure that they use a better, more efficient path to fly around that weather pattern that they're trying to face. So less turbulence can be made and less issues can be made in flight. The same thing can be brought on the ground as well. I think that's where the direction will go towards. But again, as I said, so the sensory overload topic that experienced pilots talk about, there's a few things that are unfair that they keep saying that like they used to fly without screens or much information. Well, they didn't have much traffic to fly with as well, so they
That's
don't
true. That's
they
true.
forget to say that they can visually fly below 2000 feet and land in like Mumbai airport. Let them do that today. They can't, because there's so many aircraft flying in the same airspace. They will create chaos if they start flying visually for landing in Mumbai airport. So they need to rely on patterns. They need to rely on the data that's coming in on the screens, and they need to listen to ATC's dispatch like properly before they can even make a move in this airspace now currently. So yeah, the times have changed. Air traffic has increased. The amount of people that are flying has increased. It's a different argument altogether. So that's what I would like to say to experienced pilots when they say we used to fly with our brains. Yeah, you could do that, but today you need data.
No, the way I always imagine it is we've made this framework which has been made say 20, 30, 40 years ago,
Hmm.
and it has taken care of things till date. Now the thing is, because of the sheer volume of flying, you have this system that is still holding everything together, but it is bursting at the seams. And every once now and then, there are things that go through which the system cannot take care of. And that is what is leading to incidents. And it is now is the time when we expand this framework to again reevaluate. This is the need of the hour. We need to implement this so that now it is no longer bursting, but rather a smooth control. You're not really overloading the system, but you're redefining the system so that
You're
it is
just
very much
making
under.
you're just giving the system more strength to handle that data,
Exactly.
basically.
Exactly.
Or maybe in some cases, some of the systems are becoming redundant, and you have to accept it and maybe move on from those 40-year-old systems, because you actually hit the nail on the head correctly over here. The system overload is ridiculous right now. With these systems were designed amazingly well 40 years ago to handle so far. But I think it's high time that we modernize with the current technology we got outside of aerospace, to bring that in and make sure that they are robust and applicable for aerospace as well. I think that's where the next turn would be, I guess, for us as engineers to look at.
Listen, you say we should modernize. I am still crying about moving from Windows 10 to Windows 11. 10 is coming out at the end of its support time officially, and I
Yeah.
still haven't upgraded to Windows 11 yet. I have seen offices that are still using Windows 7. So, the modernization is correct, and we have to move forward, but it has to be practical, and we have to do it.
Yes, it has to be practical, obviously. I'll tell you about my current workplace. I used to work at Collins before. They never used any modernized tools for even MS Office before. They used to live in just manual Word, Excel, PowerPoint style, note taking for meetings and stuff. In my new workplace, they already integrated Copilot in every single meeting. So there is no need for writing minutes of the meeting. The Copilot is listening to all our conversation, and actually, all you got to do is make sure that it recognizes which voice is which participant, and it will then give you the keynotes of what happened in that meeting. So job is done in 5 minutes, rather than I used to take 45 minutes to remember what all was happening in that core meeting that was hosted, and then give out meeting notes. So as I say, practicality needs to be brought into aerospace as well. We are I think as an industry, aerospace engineers and also OEMs would not want to spend extra money on certification, and also the regulations are stuck in those old ways too. Um, there has to be a healthy balance that needs to be brought in, where I'm not saying that ease up all the regulations. That's a horrible idea. But at the same time, we the regulators need to also research and improve their standards of requirements, so that the OEMs could also enter those aspects of certification. That's where the balance has to be made.
As a sci-fi novel uh, reader, I can only think of all of the things that will go wrong. That AI is listening to all of us, and we are allowing AI to control so many things. But at some point, we have to give a little work to the AI.
Yes. All I can say is my job is secure, because AI cannot replace me. So good luck with that.
You say that today.
Maybe in 20 years. Yeah, I still have 20 years to draw paychecks. So that's what I'm saying. So yeah.
Yes.
Anyways, on that note, I think we discussed a lot of topics. I'm pretty sure the listeners might have a lot of questions about what we spoke about. Maybe also you guys might have caught something that may be wrong in what I might have said. So please feel free to reach out to us. We do read every single email of yours, every single comment of yours, and try to respond to it as quickly as possible. As I said in the beginning of the show, we have a lot of exciting guests that we might be bringing on soon. And we'll make the show much more regular going forward. So please stay tuned in. And people who have been still tuned in, thank you so much for listening and watching our podcast. We really appreciate you guys. And on that note, thanks a lot for tuning in. Thanks a lot for listening to our episode. And please do like, share, and subscribe. And please make sure that you drop a comment and reach out to us whenever you can, any kind of questions you may have. We are really happy to mentor young engineers who want to join aerospace as well. I have gotten a couple of good emails with really good questions for doing an MS in the US versus India, or the industry scope in India or in the US, especially during these times with H1Bs becoming an issue and job markets being scarce. I can guarantee you there could be some good advice coming from all three of us. And we'll be more than happy to discuss anything individually or on the show, however you would like to prefer. So please do keep writing to us with those questions. So please do reach out. It's completely free of cost. And with the only concern is the time, and we will try our best to make time for you guys. So yeah. All
Thank
right.
you
On
for
that
listening.
note, thank you so much. Thank you for listening, guys. See you on the next episode.
Bye.